Alright, let's talk about it quickly. So, all this was a prelude. This is what I actually needed. I didn't need any of that stuff beforehand. That was purely about practicing skills that we should already have. So nothing that we just did then was new. That was all revision of stuff that we should know. Based on how we're going, obviously using our calculator is a bit of a concern. I'd rub the table up, but doing our tables was a bit of a concern. Deriving for some of us was a bit of a concern. Some things need reviewing. Okay, obviously the assignment's first and foremost, but we need to make sure we're getting ready for our exam as well. Here I've done my function. I've got my key features, except I haven't written some key features on my graph. What have I missed?
Titles.
I should have X and Y, very good.
Yep.
That's a man who's ready to hand his assignment in. What else have I missed? Oh, I should have my function written up there, but I'm not going to do that, but yes I should. I've missed one other point in my key feature. I've got my turning point on my graph, but I haven't actually labelled it. And my turning points are negative 100 over 3 and 8 over 3. Okay, and the turning points are actually what I want to talk about here. What do we call this turning point here?
The min.
The min. What do we call this turning point there?
Max.
Why do we call them min and max? Because this is the, and this is the, but are they the maximum and the minimum? What happens if I go this way? Gets bigger. What happens if I go that way? Gets smaller. So we call this not a max but a local max. And we call this one a local min because it's the minimum in its local area. Sweet. If we had a function like, well, if we had a bound in our function that was say 10, our domain was 10 to negative 10, right? This function would eventually stop somewhere up here. And this function would stop somewhere over there. What would we call that? If that's called a local max and a local min? Global max and the global min. Sweet. In some functions, our local max and our local max and our global max are the same point. Can anyone think of a function where the local max and the global max might be the same point? Parabola. So if I've got a function that looks like this, that point there is both my local and my global maximum. Sweet. So what functions will have a global and a local maximum? What polynomial order? That's order 2. What about 3? No good. What about 4? Will it have a point, a global and a local max at the same point? Ella says yes. Probably. Why do you say yes, Ella? It comes back down, it'll go up, and then it will come back down, or it will go down and come back up. Even functions, remember, even polynomials can either be, or well, they either go negative long term or positive long term. They can't go both ways. Yep.
Is that supposed to be min?
Yep. And the spelling test, and you pass. Sweet. Happy with that? Do you understand global and local maxes and mins? In a normal function where there's no bounds, we don't have to worry so much about that, but if we've got bounds, where should we check? Once we've checked our turning points, if we want to find a max and a min, where should we always check if we've got a domain on our function? What part of the function? The ends. So I always want to check, if I'm looking for the global, I want to check the bounds of my function. Gee, that was a good line. So if I was checking the bounds of this function, I'd have to check those 2 points there. Sweet. Good. We can differentiate between global and local max and mins. We can find them and we've practiced. Awesome.
Will there always be local